Okay, so we're going to look at lesson 6.1. We're going to go through these notes. This is outcome R3. So we're doing a lot of the same of slope, rate of change, stuff that we were doing in chapter 5. We're just going to formalize it with the actual equation here that we have if we're given 2 points. So if we have a graph and we're asked to find the slope or the rate of change, those two are the same thing. They mean exactly the same thing. What would I be doing if I have a graph? I've got these two endpoints that end off in nice corners. I could also find nice points here and a nice point here. So you see what I mean, where it goes exactly through like a perfect point? So to figure out my rise, I'm going to count how many I go up before I go over. So I go 3 up and 2 over. So my slope is 3 over 2. Now, if I look at this entire line from E to F and go all the way up here to where it lines up with this point, I go up 9, right? And if I go all the way here, then that means I go across how many? 6. So my slope in that case is, my rise is 9 and my run is 6. But what does that reduce to? It reduces to 3 over 2, which is exactly the same answer as we got here, right? So it doesn't matter which 2 points you pick on the line, as long as you pick points that are perfect, that end up on a corner somewhere, and then you reduce it, you should end up with the same slope. All right, so let's have a look at B then. So what do I notice about the difference between this line and this line? So this one's sloping down, whereas this one here sloped up. And this slope ended up being a positive slope. So what do you predict is going to happen for this? What kind of a number should I end up with? A negative slope. Okay, because it's going downhill. And this one was uphill. All right, so now if I go down, how many units am I going down? One, 2, 3. So to indicate the down, I'm going to use a negative. And then to go right, how many units do I go right? 6, 7, 8, 9. 9? Okay, so then my slope for this one is negative 3 over 9. Now, can I reduce this as a fraction? It's going to be negative 1/3. So the slope of GH is negative 1/3. Okay. Let's have a look at this. Here we have to draw a line segment for number 2. We're going to start at negative 3, negative 2. So that we're going to use each line as a 1. So this is going to be negative 1, negative 2. And then I go negative 3. Okay, so that's x is negative 3 is right here. And then I go down 2 and I meet up right here. So this point, if I label it, should look like negative 3, comma, negative 2. All right. Now from here, I run a slope of 4 over 9, which means that my rise is 4 and my run is 9. So I go up 4 and right 9. So from here, I go 1, 2, 3, 4. And then I go over 1, 2, 3, 4, 5, 6, 7, 8, 9. And what's this point that I end up at? 6, comma, 2. So I've got these 2 points, then I need to connect them with a line. Make sure you use a ruler to connect those 2. Okay, now, as a prediction, what do you think this slope is going to look like as compared to part A? This is going uphill, and this is going to go downhill. So it should look like that because of the negative in front. So I've got this -8. So what I'm going to do is I'm going to say it goes down 8, and then I'm going to go right 3. And the down is because of this negative right here. So let's first plot our point 2, 3 and start from there. 1, 2, and then up 3 lands me right there. And then I'm going to go down 8, 2, 3, 4, 6, 7, 8, and then over 3. 1, 2, 3. All right, so what is the value of this point right here? 5, -5, and I'm going to connect the 2 dots with a line. Good? Okay. Now let's draw a line that is positive, negative, 0, and undefined. So a positive slope was just like this here. A negative slope is just like this here. So we're just drawing anything. It doesn't matter exactly what the slope is, just so you can recognize what it looks like. Positive slope, it's uphill, okay? And a negative slope is going to go the other direction. Okay, and it is downhill. And then we've got a slope of 0. So a slope of 0 is a horizontal line. Okay, so it's a horizontal line. What can you tell me about the rise here? The rise is 0. And so you end up with something like, and does it matter what the run is? I could say it's any number, right? 0 over 1, and that reduces to 0. And then for an undefined slope, that's going to be a line that is vertical. Undefined slope. What is my run here? So it doesn't go across anywhere, right? So if I were to fill in a number for rise over run, I would have, let's say, 1 over 0. What can you tell me about this number here, 1 over 0? It is undefined. There is no, makes no sense, right? Can't break something up into 0 pieces. All right. So let's look at number 3 then. So number 3, you're given 2 points. Excuse me. You're given 2 points, and you have to figure out the slope of this line that's made up of those 2 points. So you've got 2 ways of doing it. We could use the equation, or we could just plot the 2 points and graph them and count it out. Okay? So let's first use the equation, and then we'll graph it after. Okay? So if we're looking at this, what are we going to call this? This is going to be x1. This is going to be y1. 8 is going to be x2, and 6 is going to be y2. So we pick one as the first point and the other one as the second point. Remember final and initial, that idea? So, and then we find the difference of the y's. So the difference of the y's, so y2 is 6 minus, now if we're minusing a negative, make sure you have a bracket there so that when you're working this out, that ends up being 6 plus 5, right? And here we've got x2 is 8 minus positive 4. So this is 6 plus 5 over 4, and that equals 11 over 4. So this is the answer to the slope of that line. Now let's plot the 2 points and see what our rise over run ends up being on our graph. And it should be the same thing, right? Okay, so let's plot 4 and then down 5. So that's point E. And then let's go 8 and 6 ends up right here. So this should be F. So if I take a ruler, that's what it looks like. That's my line. And if I count up, how many do I go up from here to there? From E to F? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I go up 11. And then from here, how far do I go across? I go right 4. So my slope, by counting, is 11 over 4, which gives me the exact same answer. You only need to use one method to figure something out, but there you've got to check. Any questions? Okay. So let's have a look at number 4 now. Number 4 says, Tom has a part-time job. He recorded the hours he worked and his pay for 3 different days. Tom plotted this data on a grid. What is the slope of the line through these points? And then we have to figure out what does the slope represent, and then how can the answer to part B used to determine how much Tom earned in 3.5 hours and the time it took to earn $30. Okay, so right now we just have dots on the graph, right? So in order to get a better idea, I can connect them if I wanted to, just so that I can analyze it a little more. So that's the general trend that's happening. Now, what is the slope through these points? So let's pick this point and this point, for instance. I can pick this one and this one here if I wanted to. What is the rise from here to there? Watch your scale. What's 48 minus 24? Okay, so then I go, it's up 24, okay? So that's 24. And then what's my run across this way? How many does it go to the right? Okay, are we sure? Yeah? Okay. So we're going to watch the scale, make sure, because that does happen quite a bit, where you have a different scale and you're just counting the squares and you make a mistake because of that. So watch your scale. So what does this mean here? 24 over 2. What is my slope? My slope is 12, right? So for every hour passed, you make $12. For every hour passed, Tom makes another $12. So really, in real life, what do we call that? We say that he makes how much? $12 per hour. Okay. So if he makes $12 per hour, he makes $12 per hour, how much does Tom earn in 3.5 hours? So 3.5 times what? 12. So that equals $42. So he makes $42 in 3.5 hours. Okay, so that's the first part of C. Now the second part of C is, how much time did it take him to earn $30? So it's kind of like the same setup here, but what do we not know? We know that he makes $30. We know he gets paid $12 an hour, but we don't know how many hours he worked. So you see this little equation that we've set up that is modeled directly from here? So it's like x times 12 equals 30. So if I solve for x, I get x is equal to 30 over 12. And what is that? 2.5. So Tom works 2.5 hours to make $30. All right. So then the homework is in there.